Okay, guys. All right. So before we do our Spanish tree lab, okay, we got a lot of things to cover on that lab, and when Spanish tree is taught, okay, it's always taught with three switches, okay, but not with me, okay. Minimum four, okay, and then we use packet tracer to map out what we think all the actual devices are going to be and what the ports are going to be, and then turn all the switches on or cable them up, really, because the switches already are all on, and see if our calculations is correct. Okay, all right. Now, from that perspective, it puts me under the microscope too to see if my understanding of spanning tree is still as strong as it used to be. Okay, that is the goal. All right. Okay, meaning that if I can embarrass myself, your embarrassment should be very minuscule. Okay, meaning that you should be getting to the point at some point that failure is part of what is part of your success. I don't know why I said it twice, but still. Okay. Plus, I gotta find two switches to add to my lab, and relocate them because um, you know, I believe in physics. Basic physics should be, and I'm talking about just basics. Okay, all right. Anything from thermodynamics to weather to pulleys to um, loads. Okay, uh, the basics of physics is something that everyone should have part of their intellect, and that just isn't the case. Okay, so what my mother built for me to actually access my switches is very, very, very dangerous. So I have to, um, the chances of it coming down with me moving the switches on top to put console cables in, yeah, it can be very catastrophic. So I have to move those switches to a better design, and so on and so on. Okay, so um, what I want to talk about today is Etherchannel. Okay, all right, and then we're going to stop until I get my lab set up because that means I'm going to be one lab ahead. Okay, all right, and Etherchannel is going to be a very, very short video. Okay, now remember, okay, with Etherchannel, okay, the concept of Etherchannel, oops, is having multiple links. Okay, now what's happening here? Okay, we all know now we have a loop, and in that loop, okay, all right, right now we're going through our learning stage. Okay, can I change these fonts? It's been a while. I guess not. It must be in the options. Uh, oh, excuse me. There we go. Okay. Now, as you can see, okay, there is our port priority number. Okay. All right. This is the lower one. Okay. So F801, which is which one? Okay. Well, I know which one it is, but let's go ahead and shut it down. That is the top one, okay? And of course, the lowest always wins, which will make sense. Okay? Alright? Now, FAO1 is now at the bottom of the list because it's, second, the newest interface that came out. I don't know if that's always the case, but all right, we're going through our learning stages. We've gone through our listening, and now we're forwarding, okay? Because FAO1 has a lower port priority, which is 128.1, obviously, because the point 1 would say, hey, I'm port 1, right? Okay, and port is lower than 128.2, it wins the election, okay, of who is going to be forwarding, okay? All right, now, that is the only case, all right, in most cases that you're going to be going down to the port number or the port priority or whatever whatever you want to call it, okay? Now, hold on, I'm kind of doing stuff at the same time. My nose is driving me nuts, as usual. So I can get tissues. Okay, so what if? Because you gotta understand something, okay? Regardless, if switch 0, the one on the left, is sending data over on port 2, okay? Switch 1 on port 2 is blocking that data. So, you could be using bandwidth, but you're not going anywhere, okay? All right? You might be sending data down that port, sucking up the bandwidth, but that other port is dropping it. So there's no transitioning of that data. It goes nowhere. It's a dead end, okay? Now, but here's the thing, okay? I might have redundancy, okay? I might have 100 megabits per second going down that link. Now, one of the things that we haven't discussed, which I don't think we have, is because we're using full duplex, being able to communicate both ways. A 100 megabit link literally gives us 100 megabits both ways, giving us 200 megabits of bandwidth. Okay? All right? Not the same case in half duplex. Now, what if I had the ability to use both links and get my full bandwidth in full duplex both ways? Because right now, I only have one link. And the way to do that is to, in a sense, trick spanning tree in believing that this is one link. Okay? So, first of all, yeah, I'm tired, guys. Sorry. Alright, so let's do a show Etherchannel. Okay? Nothing's there. First thing I'm going to do when configuring Etherchannel, okay, is we got to understand two things. One, there's two specific protocols. Okay? LACP, okay, alright, and if you look at the first two letters, LA stands for link aggregation, okay, alright, now, with all these acronyms in my head, I usually see C as the word control, okay, and not not the proper word. So I don't know if that's a control protocol. I just know that that is a bad habit of mine, and it has not erased in the 15 years of my existence. Okay, so for right now, we're just gonna look at link aggregation. I'm not gonna even look it up. Okay, so now, all right, I'm trying to stay on point here with my exhaustion. And you know, it's funny. I mean, I just woke up. You know, yeah, I see the time. Okay, but at the same time, um, you know, hey, it goes with the territory. So now, link aggregation. Okay, that is the industry standard protocol for binding up links. Meaning that if I had a Juniper device and a Cisco device, I can actually communicate with the same protocol, okay, with Juniper and link my links together, okay, making each switch to Juniper and the Cisco device believing, matter of fact, I can give me a Juniper device too, making it believe that those multiple links are one link, okay? All right, so now, PAGP is Cisco proprietary, okay? All right, now load balancing and load sharing. Now, I want you to think about this. Let's think of the difference of those terms. Load balancing is the concept of evenly balancing the data across multiple paths. Okay, load sharing is we're using all the links or multiple links. Okay, not saying we're using all of them, but multiple links, but it's not balanced. Okay, so there is a difference. Okay, and if you want to be technical when you're teaching some of these protocols, that would really go hand in hand. Okay. All right. Now, what we're going to do is we're going to create our channel link. Okay. And the first thing we're going to do is we're going to go into two interfaces by saying interface range FA01 to 2. Okay. Now, if I want to specifically select individual links like FAO1 and 5, okay, I would do it that way. But because they are in sequence, all right, I'm saying, hey, I want to do every port from 1 to 2, all right, or I could say 1 to 24, okay, all right. Now, first thing I'm gonna do is I'm gonna shut these down, okay, all right. As an engineer, okay, there's nothing now in the lab. This is going to happen to you all the time, which is good. Okay, I want you to fail. The more failure you have, okay, the better you get. Failure is growth. Okay, all right. In my CCNA days, I had the ability, a mental ability, to change failure into a successful thing, and it's not easy. When you take your first exam and fail, you feel unworthy, you feel that you're not smart enough, and it is a boulder that is heavier than the earth itself. Okay? All right? All right? And if you really want to be catastrophic, people that I know, which I still to this day would never understand why, but has never taken a CCNA exam again since their first attempt, by missing the exam passing by 1 point. Never did it again. Okay, it's that powerful, and I relate to that power until I started rethinking what failure really was. Okay, all right, and how necessary it is. It takes 1,000 failures to make a success. So I want you to fail as much as possible to get it out of the way as soon as possible. And as soon as possible is years down the road. Trust me. Not on a particular topic, because once you go into a new topic, that failure rate starts all over again. Okay? So, but in the lab, you're not going to shut the ports down. Okay? And then these ports are going to go into air disable mode because you're going to configure one side, the other side's not the same, and it'll just, the ports is going to shut down. You're not gonna pay attention to the console port messages, and you're sitting there troubleshooting with shut down ports. And the only way to bring them back is to shut the ports down and then bring them back up again. And then what's going to happen is the misconfiguration is going to kick in again. It's going to shut back down. Okay. So as an engineer, shut down your ports before you do any configurations, especially something like Etherchannel. Okay. Okay. Channel group, and I'm going to select the number 1. Every version of the iOS or every platform has a certain amount of channel groups you can do. With these 2950s, we can only do 6. Okay? Alright? Don't know if it's platform or iOS version, don't really care. Alright? It gives me the number right there. Okay? So, and of course, research is the most important because you might be able to have more than 6 and just need an iOS upgrade. Make sense? Okay? So now, channel group 1, mode. Okay, and I'm going to say, yeah, look at those. Active, auto, desirable, on, passive. Yeah. What is my take on this? Okay, all right. Those names are kind of familiar, right? With trunking. Okay, all right. And even the nice thing about the iOS is it literally most of the time gives you most information that you need to know. Okay. Active and auto are 2 different protocols, okay? So that means when I'm configuring this, I have active on one side, I can have passive on the other because they're both LACP, okay? Auto and desirable, well, that sounds like a Cisco terminology, right? Okay, but automatic to me means auto should not do it, remember? So I'm just going to say on. Okay? Now, how the hell... and you know, this is what trips me out, yo. Check this out. It's administratively down, okay? Right? The protocol is down. Oh, my bad. My bad. I misread it. Okay. So... because like GNS3, okay, even though you shut down the interface, it's still status is still up, meaning that you can shut down an interface, okay, all right, and it'll still be in the routing protocol. This is one of the problems I had with GNS3 way back in the day. I don't know if it still does it or not. Don't really care. Okay, from that instance, when I spent hours and days troubleshooting why a route was still there. Because I shut down an interface to make the route go a different way. Trace route was showing it going in the same direction. Okay? Because that interface never shut down. Alright? It was always active even though I was shut down. Okay? That was the last time I used GNS3. Okay? Alright? Remember, guys, you're not learning the platforms like you think you are. You are learning the operating system. And if the operating system is not doing what it would do in real life, you're causing yourself an injustice. Okay? That's why I have physical equipment on my desk. Alright? Now, show interface port channel 1. Okay? Show IP interface brief. Aha! Okay. Come on. Okay, notice that this is up and up. Impossible. Okay, now I don't know. Okay, if this does this on a real switch or not, doesn't really matter. Okay, what matters is my port channel is there. Show Etherchannel. Okay, but in Etherchannel it isn't up because it's down. Okay, the ports are down. As a matter of fact, what is going on here? I'm on switch 0. Why are these green? It is doing it. Okay, so that's my point right there. You can't have green interfaces when the ports are down. Okay, so that's, when we do our real lab later on, Okay. Yeah, we're definitely going to be using real switches. Okay, so, but Packet Tracer has its benefits. And I've always liked the program or the application, but I don't use it for real study. Alright, for teaching, it's great. And I mean, really great. Alright, so, config T. Alright, interface. No point in looking at the stuff if it's going to give you false hope. Interface range. 2. Really? Wow. Okay, that's weird because channel protocol. My bad. Okay, channel group 1 mode on. Okay, now I don't need to shut these down. Okay, which are they down? I don't think so. No, they're not administratively down. Okay, so you can see right here. I don't have to shut this one down because my other ones are shut down. Okay, you do not want negotiation from one switch to another where it is misconfigured on each side. I don't care what you're doing, even a trunk leak. Okay, all right. As an engineer, shut down your ports. Okay, now these green lights are false. So now let's do a config T interface range. FAO 1, 2, no, 3, 2, no shut. Now it's changing to up. Okay. Come on. All right. Okay. Look at what we have here. We no longer in spanning tree have our individual ports 1 and 2. We have port channel 1. And look, all forwarding. Okay? Port channel 1, the number we gave it, supersedes the belief that FAO 1 and 2 exist. Okay? And now, port channel 1 with 2 links is now 1 port with a cost of not 19, but a cost of 9. Okay? Which would make sense. Okay? So now, if we do a show interface, port channel 1, oh, okay. Well, that's interesting. What are options? Oh, really? Well, that's interesting. I've never had 2560, so I've never noticed that before. Okay. But in our Etherchannel, okay, you have FEO1, FEO2. It gives you some information here. It tells you what channel group you're in. Okay, what your port state is. Okay, your load. All right. And okay, not the command I was looking for. Okay, not the command I was looking for at all. Okay, so we can't look at the interface. So, you know what? I'm gonna leave it at that. This is teaching, not labbing. Okay, so, all right. So now, let's go into our port channel now. Okay, because now remember, all right, this is your first instance with the teaching from me to you as looking at configuration of a virtual interface. Okay, so now interface port channel 1. Okay, now this is the thing. Ideally, do show interface FAO1. No. Do show run. Are you serious? Okay, okay. Notice that under each interface, okay, I put a command in channel group 1 mode on, okay, and they're in there. And yes, the the port channel number has to be the same in order for you to be in the same bundle, okay? Now, all right, so my commands won't work, but there's always one way to, more than one way to skin a cat. So now, interface port channel 1, shut down. Okay. Okay, now here's the thing. Because I shut down the port channel, okay, I can't remember if the interfaces should shut down or at least the protocol shut down. We won't know that until we get the live switches, okay? Which we won't realize that until we get to the lab, if I remember to actually bring it back up again. And, however, anything you put underneath the port channel, okay? Yeah. That 15 years later, that still messes with me. Okay, so now, all right. Okay. Before we do that, look, I did it under the port channel. If we go back up, okay, I'm in the port channel. Ideally, whatever you configure under the port channel should automatically inherit in the ports within the port channel. However, as an engineer, okay, it doesn't always take. You should always do your show commands to make sure they inherit it. Sometimes you have to go under each interface of that port channel and manually put them in. Okay? All right, you call it a bug, you can call it whatever it is. It's just experience. It's talking here. Okay. All right. So now, interface range F80122. Okay. Notice that I'm already in the range, but I always manually put them in. I can't tell you how many times I've misconfigured something, believing I'm in a port range. Okay. If I can't see it, it's not listed here. I am retyping in the command every time. Accuracy is much better than speed. Okay? So I have no plans of having exhaustion from retyping these commands in every time to make me know that I'm in there. I want to see it on my command line. Okay? Does that make sense? All right? These are just the things that you acquire over time. Okay? Dumb mistakes, okay, trust me, you getting written up on at work has nothing to do with the stress you're going to put on yourself of making a dumbass mistake like that. Okay? Because you're going to sit there and you're going to be like, God damn it, man, that's a rookie mistake. What the fuck? Right? And you're going to make yourself feel, but you're going to make yourself make sure you don't do it again. All right? So now, switch port, mode, trunk. Okay? Now, no shut. Okay? Are these shut down? Oh, I guess they were. Okay? Show, interface. Now, it's your port channel, that's the trunk. Okay? Alright? You see what I did there? Okay? I'm using packet tracer as a means of teaching you and seeing what's happening here. Okay? We have no block links, and we're using all the bandwidth. Okay? However, Etherchannel is not what you think. Okay? If I would have did a show interface on the port channel, you would see, okay, that the port channel was 400 megabits per second. I'm sorry, 200 megabits per second. Okay, all right. Assuming that these are 100 megabits per second. Okay, you wouldn't see it as 400. You would see it as 200 megabits per second. However, Etherchannel, okay, doesn't work like you think it is. All right, and one of my famous labs, which I'm sure I still have it recorded. I might actually upload that as a means of bypassing it, but we can't really do that because this is 2024 recordings, okay, or 2025 now. So we have to go to the lab. So now, I'm not uploading anyway. It might give you, you know what? It'll give you an understanding of how I used to teach and how I do things now. Over a period of time, you start realizing that covering everything isn't really necessary. We gotta take baby steps, right? Okay, and you start to realize that, you know, it ain't really necessary in a lot of ways to do a lot of talking about technology because there is a gradual frame of time where you as a student is going to check out, okay? Especially on new topics. Now, in the interface command of port channel 1, you're going to see this is 200 megabits per second, okay? All right. However, you're not going to be load balancing across these links. Okay. This is how Etherchannel works. Okay. Every link, okay, is ran through a hash. Okay. And as the data is egressed out of each switch, okay, that switch runs a hash algorithm before it sends the data and chooses a link to send that data down. Meaning that I have 2 links in my bundle, but for transmission, I'm still not getting more than 100 megabits per second because I'm only choosing one link. Meaning that if that link gets flooded with as far as saturation of bandwidth, hey, that is what it is. Now, I'm pulling from years of documentation that I have not read in years. Okay, so do your own research. Now, there is a way for, you know, switch 1 might choose link 1 or FAO1 to send its data as it egresses. Okay, and switch 1 might choose FAO2, okay, as its link, okay, for egress. Now remember, this is only for egress traffic, okay? It does not determine as data is coming in, okay? All right, its neighbor switch determines what link to choose as the data is going out to the, you know, to its switch, okay? Now, think of it like this. If switch 0 chose FAO1 and switch 1 chose FAO2, you are using the full bandwidth capable. Okay? Technically, you can say you are moving traffic at 200 megabits per second. Okay? However, that's not usually the case. Okay? All right? I doubt if this command is here, but let's find out. You know, it is just an application. It is there. Oh no, that's not the data I wanted. Okay. As you can see, okay, we could change the way we load balance, okay? Which technically is load sharing, it's not load balancing, but I'm not going to argue with the iOS. We could change the load balancing mechanism. In this case, we are load balancing across the links or load sharing across the links using the source MAC address as its determination. So, okay, we can change this. I was expecting to be in there, actually. Okay? Alright? So, there is a way that you can think of this, okay? And, think of it as if we set it to source and destination IP address, okay? Alright? Everybody who's going from the same source to the destination, and same destination, is going to hit a particular link. Okay? Alright? Once that number changes, we're going to choose a different link. In theory, okay? Alright? It does not mean that once you make this change, that every bit of different IP addresses is going to choose a different link. They might choose the exact same link, and you'll saturate the hell out of that one link. Okay? Alright? Well, let's say, like, source MAC address. Okay, this will be great to use when you're going into like a server farm. Okay, because every bit of data that you are sending out will be load balanced across the Etherchannel. Okay, in a fairly fair, so to speak, mechanism as far as choosing which port to use, and you'll see all your links in that port channel blinking. Okay? Alright? But if you do it from a source IP address, okay, that might be the same case as well. But what if you are using a server farm where everyone has the same IP address? And maybe you are having a pool of servers with the same, using the same IP address. Okay. Now one of your links in that port channel is going to get flooded, and it's going to be inefficient. At this point, after going through spanning tree in this lesson here, you start realizing that knowing this information makes you a very powerful person on the team, okay? Because you get to make things more efficient by understanding the power of the technology and the concept of what managing a switch really is, okay? All right? Some people will kill for $20. Some people use money like I do as a tool. Okay? Alright? I don't care if I lose $20. It's worth the $20. Okay? To move on and learn my lesson and never do it again. Okay? Alright? Not love money more than I do life itself. Okay? It's just a tool. Okay? Just like anything else in my life, it's a tool. Okay? Now, when someone like me loses $30,000, I move on. Okay? Alright? Some people will never move on from it. Decades later, they'll still go back and say, man, it ain't right that, that person, they'll start justifying why things happen. What if this person's the cause of it? He's the reason why. Okay? And go on a killing spree, okay, for $30,000. Okay, the point is, the more tools you have, the more knowledge you have, the more you're able to be determined, to be strong, to be Cisco. See you guys on the next one.